Once students are willing to go public with their ideas, they often need to be pressed to cite evidence, dig into the data, or deepen their reasoning by taking into account what others have found. Many students will not do this spontaneously. There are two families of moves that you can use to help students go deeper into their thinking. These are critical tools in helping students develop their scientific reasoning with data and models as evidence to support their claims. The first move might be called the "why do you think that" move. Some people call it press for reasoning. There are many, many ways to say this, but all involve probing for evidence, data, or reasoning by asking, why do you think that? What's your evidence? How did you arrive at that explanation? Where in the data do you see evidence for that claim?
Lisa?
I think the water will go up. I think the water will go up.
Okay. Why?
Because you threw the rock in there and the rock is gonna make the water go up.
Why is the rock going to make the water go up?
I think the volume in the water, the cup will decrease when the water freezes.
Okay. Volume will decrease as ice.
Yeah.
Does that sound like what you're trying to say? Why, though? So we're looking for your claim, and we're going to be looking at this at the end, but also for you to state why. What's your reasoning behind it? So why did you say you think the volume will decrease?
Because because the solids are heavier than the liquid.
Water rise.
So this group found that it was the volume. What was it about your observations that showed you it was the volume and not weight? Because you had a different idea than Kyle. How did you know it was volume? Okay. And Johnny, can you give us some ideas of why you made that claim?
Because it's the volume.
And how did you figure that out?
Because when you put the plastic in, the water couldn't go nowhere, so it just rised it up.
Do you have some different ideas about what earth materials are? Are there some things up here that need to come off?
Grass.
Grass, why?
Because it's not an earth. Because it's not an earth material.
Why? Can you explain why?
Because it's not like something like gravel or soil.
A second way that you can press students to dig deeper is by providing a challenge or counterexample, or tossing back their own question to them. Does it always work that way? How does that idea square with Sonia's example? Or what about Greg's data? Doesn't that contradict your claim? Or, that's a good question. What do you think? You can also use a hypothetical example as a challenge. What if we had used the copper block instead? Would it still work the same way? The point of a challenge or counterexample, as in playing devil's advocate, is not to tell students that they are wrong and get them to change their mind. Rather, it's to help them dig deeper, think harder, and complexify their thinking. In the following clips, you'll see different teachers pressing their students to go deeper, using a variety of these moves.
Okay. Now when you said it's still, if I look at these two containers right now, both of those liquids look still to me. Neither of them are moving. So can you kind of expand a little bit more on what you meant when you said one is still and the other isn't?
What I mean is that if you shift the water.
Because the water and mineral oil, they're almost the same except 2 grams away.
But it's almost the same, exactly the same.
Almost.
What do you think, Lucas?
Well, I'm kind of confused about the sandstone. Well, some of the investigation. How are we supposed to find out? How are we supposed to find out how many? If it had to do with the volume?
Well, who can answer that question? How can we figure out if it had to do with the volume or weight?